Okay, so this is a first question here. Three voltmeter are connected in series across a 120 volt DC supply, and the element which connected in series of the voltmeter are given here. First is 100 volt supply and 5 milliampere is flowing. Second is 100 volt supply and 250 ohm per volt. Third is 100 millivolt ampere, 5 kilo ohm value. So these are the three voltmeter connected are in series. So what are the respective voltage for the each voltmeter you will get with this 120 volt DC supply. So you need to find out the reading of the each voltmeter with with considering these parameters. Okay, so try to solve it. यस गाइस, क्वेश्चन समझने में किसी को प्रॉब्लम है तो पूछ सकते हो आप. सर्किट समझ में आएगा आपको. सी, थ्री वोल्टमीटर आर कनेक्टेड इन सीरीज. ओके, so this is a voltmeter 1, this is a voltmeter 1 connected with this voltmeter 2 and 3 in series. So these are the 3 voltmeter which is further connected to the DC supply which is 120 volt. So this supply is 120 volt, 120 volt. You need to estimate the reading of each voltmeter. So this is a voltmeter 1. Okay, let's say this is your V1 voltmeter 1, this is your V2, and this is your V3. So these are the parameters is given to respective voltmeter. You need to find out the reading of the each voltmeter. You are supplying 120 volt DC supply to this combination. So see, this value is already given to you. This is nothing but the IFSD for this voltmeter, and this is the sensitivity parameter, right? So by this, you can easily find out the IFSD, right? Because sensitivity is inversely proportional to IFSD current, right? So by this way, you can easily find out the current, and this third term is value is given in terms of this kilo ohm. Okay, so either you can replace this voltmeter with with their internal resistance. Okay, so and find the total current flowing in that circuit, and by this way you can find out the voltages. So for voltmeter 3, 100 milliampere which is given here, nothing but your IFSD current. Okay, so try to solve it. This is the first question. I will give you 3 to 4 minutes. Okay, and second question is this. So I hope आपने ये सब क्वेश्चन नोट कर लिया होगा. क्वेश्चन 1. ओके, सो ये आप सॉल्व करो. एक क्वेश्चन, एक डाउट था ना स्टूडेंट का लास्ट टाइम कि हम एब्सोल्यूट एरर को हमेशा ऐड क्यों करते हैं वाइल एडिशन, एंड this percentage error is always add in irrespective their multiplication or division. Okay, so why we are adding? So I already explained them ki, when you take the reading, so you got the observation ki, when we add the absolute error. Okay, the for example, see, if the resistance value R1 is given to you, which is nothing but your 100 plus minus of 15 ohm is given to you, and R2 is nothing but your 10 plus minus of 10 ohm is given to you. So when I add these two resistance, okay, so what are the R1 plus R2? See here, the absolute error is given. So if I forget about this error, so what are the actual value? 100 plus 50, which is nothing but your 150. 150 ओम ये आपका एक्चुअल वैल्यू रहेगा जब आप दिस अनसर्टिनिटी को निग्लेक्ट करोगे. बट this is present in your resistance. It means what is the range of this R1 resistance is plus minus 15 ohm. So this is range is nothing but your 15 85 ohm to 85 ohm to 115 ohm, right? And similarly for this R2 range is 40 ohm to 60 ohm. मैंने लास्ट टाइम जिसका डाउट था ये, एट दैट टाइम आई टोल्ड देम when you take the reading and take the observation, you got the such a condition. uh, in that condition you always add this absolute error while addition and subtraction. Okay, why? See, because you add here while performing the addition or subtraction. I am considering addition. Similar concept for the subtraction as well. Okay, so when I consider the minimum range में इसका actual value क्या मिलेगा हमें? When I consider all error is present. Okay, so what is the net value is 5 plus 1 this 125 ohm, right? While performing the addition, so this is the actual value you will get. So but when you neglect this error term, so what is the value is 150 ohm. So I can say uncertainty present in this 150 ohm is nothing but your 25 ohm, right? Then only at a minus condition you will get when the error is minus, or when the error is reduces the actual error. So मैक्सिमम कितने वैल्यू से उसको रिड्यूस कर सकता है? 25 वैल्यू से, राइट? 25 ओम. सो एट दैट टाइम यू गेट द answer is 125 ohm. That's why. And observe these two values. So this absolute error, when you add you will get 25 ohm, right? So that is nothing but your this uncertainty. So that's why while performing this addition and subtraction, you will get such a condition. So such a condition by which you can't lose your accuracy. But the same question when is given in terms of percentage, अगर यही क्वेश्चन परसेंटेज में दिया है, फॉर एग्जांपल 100 प्लस माइनस ऑफ 15%, which is equal to 50 plus minus of 10%, and then you perform the addition r1 plus r2. So r1 plus r2, this is nothing but your 150 and plus minus, and if you add this percentage error, which is nothing but your 25%. So what are the 25% of this 150? कितना आता है यहाँ पे? See, this is a wrong calculation, but I do that because we analyze the both these two things. So what is the value of this 150 ka 25%? Okay, so when I calculate this, which is nothing but your, here you need to find out the absolute error. Okay, so 150 multiply by, sorry, plus minus, actually this is a multiplication, so this is your plus minus of absolute error. Okay, so this is nothing but your, okay, and this is nothing but your 75 divided by 2, which is nothing but your plus minus of 3 to the 6 1 37.5, right? 37.5. So you got 37.5 as your absolute error. So 150, what is the range? 150 plus minus 37.5. So at this time you will get this 150 plus minus 37.5, but this is wrong, right? Compare these two things. This is the actual when we observe the, when we consider the specify range. Okay, when I consider this error, so we will get this specify range. But when we consider this percentage error, so at that time, if you directly add this percentage error, so you will get uh, absolute error is plus minus 37.5, but this 37.5 is greater than this actual error. Okay, so at this time this calculation goes wrong. So that's why while performing the addition and subtraction, you will always add this absolute error. Similar way you can also analyze, while performing the multiplication and division, you will get, you always add this percentage error, not a absolute error. So by this way you can analyze and वेरीफाई योर आंसर. ओके, सो मैंने उस एट दैट टाइम कहा था कि आपको ये मैक्सिमम वेन एवर यू टेक द रीडिंग, सो यू आर जनरली ऑब्जर्व दैट दैट रीडिंग while performing the addition and subtraction, you got this, you add this absolute error, so that reading is a match with this error. So these are the numerical, hmm, you can say, verification of that concept. So you also verify the percentage error. So while taking this percentage addition in when you take the multiplication division, the value is slightly very near to the uh, perform calculation value. So when you do the multiplication and division, always percentage error is added. Okay, so these are the that student doubt. This is a numerical verification of that doubt, their doubt. Okay, so yes, guys, what are the answer you will get here? प्लीज रिस्पॉन्स, कितना आंसर मिला आपको इसमें? Yes, guys, anyone? Total almost 55 students are there. So what you will get here? What is the value of V1?
48 volt.
V1 48 volt. Okay, V1 48 volt. What is the value of V2?
60 volt.
60 volt. What is the value of V3?
12 volt.
12 volt. Okay, so let's check these values. I hope most of the students are able to solve this problem. So now see, okay, so this is your V1. V1 value is 100 volt and 5 milliampere is given to you, and V2 value is 100 volt, 250 ohm per volt, and V3 is 100 milliampere and 5 kilo ohm. Now one point is a note here. These all meters are connected in series. So you need to find out the full scale deflection current. By finding the full scale deflection current, you are decided here how much amount of current will flow through the circuit. So by this means your meter will not be damaged, right? So now, yes, so this uh, voltage is given here. Okay, in this question, in this question of each meter, uh, voltmeter. So uh, you can also find out the value of resistance. So yes, so this is your 100 volt. Okay, and 5 milliampere is flowing through this. So 100 volt divided by 5 milliampere, which gives you a resistance of this V1, right, voltmeter 1. So what is the value is 20 kilo ohm, right? Because this milliampere goes in numerator side, become a 10 to the power of 3. And this is simple calculation. 520 is a 100. Okay, so this is for your this meter 1. R2 value is here, the voltage and the sensitivity is given to you. Okay, so sensitivity is nothing but here 250 ohm per volt. Voltage is given to you. Okay, so voltage is given to you. Once you divide that uh, yes, once you divide that voltage, okay, so you will get the value of resistance of these two. So this is the sensitivity. What is the formula of sensitivity? 1 upon r, 1 upon r, 1 upon r by v, right? R by v. So simple. Do that calculation. So this r is equal to 250, r by v is equal to 250, right? So r into 250 into v. What is a v value? Here is 100 volt. 100 volt is given to you, right? So 250 into 100, which is nothing but your 25 kilo ohm. So this is your R2. And what is the third one is 100 milliampere and 5 kilo ohm. So this is a milliampere and this is a 5 kilo ohm. So 5 kilo ohm is with you. So no need to find out of R3 here. R3 is nothing but your 5 kilo ohm. So all resistance you are able to find out here, and voltage supply is given to you. So sum the all resistance and find out the total current flowing in that circuit, which is id. Okay, so id find करने के लिए redraw that circuit, which is 20, 25 and 5. All values are in kilo ohm. Okay, 120 volt dc supply is given in your circuit. So when you find out the idc, this is a 25 plus 25 50. So idc you will get here 120 divided by 50, which is nothing but your 2.5 milliampere. And yes, when you find out the v1, v2 and v3, multiply this 2.5 milliampere with their given value of resistance. So this is nothing but your 48 volt, this is 60 volt, and this is 12 volt. Okay, so here only the voltmeter are connected in series. You need to just find out the value of uh, voltage measurement. See, so these are the measuring value of that voltages. Okay, now second question. This is the second question. Please note that question and try to give that answer. Okay, here you need to find out the calculate the maximum uncertainty present in power factor will be. So please read out this question. So what is the basic formula of power? Power is nothing but your vi cos phi. Vi cos phi. So here you need to first of all find out these three parameters. Okay, so power factor, you need to find out the power factor. So power factor is, from this equation, is nothing but your P by VI, right? So you need to find out the uncertainty present in this power, voltage and current, and take that combination. So by performing this calculation, you can easily find out this uncertainty present in your power factor. So what you will get given in this question is, the power factor and the phase angle of the circuit carrying the sinusoidal current are determined the measurement of the current, voltage and power. The current is 2.5 ampere or a 5 ampere emitter, and the voltage are 115 volt on 250 volt voltmeter. Okay, now the power as 220 volt and 500 on a 500 watt wattmeter. Power is 220 watt on 500 watt wattmeter. The emitter and the voltmeter are the guaranteed accuracy width of this plus minus of 0.5% of full scale deflection, and a wattmeter with a plus minus 1% of the full scale reading. So these are the full scale diffraction guaranteed accuracy is given to you. So this is nothing but your full scale guaranteed accuracy error. So you need to find out the limiting error here. Once you find out the limiting error, that limiting error is with respect to with your measuring value, right? So for in first in emitter, full scale reading is 5 ampere. So 5 ampere के लिए what are the guaranteed accuracy error is plus minus of 0.5%. Okay, see, this is a emitter and voltmeter, both are guaranteed accuracy is plus minus 0.5%. So for 5 ampere plus minus 0.5%. So uh, when you measure the current of 2.5 ampere, what is the percentage error? That is, we already see the relation between limiting error and percentage error, right? So true value into limiting error is equal to full scale value into the guaranteed accuracy error. So that relation use in this question, and try to solve this problem. Okay, so limiting error, limiting error into true value, you can say true value. Okay, or you say measure value. Limiting error into measure value. Okay, measure value is equal to guaranteed accuracy error into full scale value. By this relation, you can find out this limiting error. Okay, because limiting error is with respect to the your measure value. So in case of your this uh, voltmeter का कितना है 115 वोल्ट इंटू 250. सो इफ आई टॉकिंग अबाउट द वोल्टमीटर, गाइस सॉल्व करो इसे एंड आंसर बताओ. वोल्ट मीटर got the measure value is 115 volt, and full scale value, this is your measure value, right? And this is your full scale value. Okay, I think 250 volt. Yes. So and accuracy, guaranteed accuracy is plus minus of 0.5%. In terms of percentage or absolute error? Percentage. Okay, so limiting error here, limiting error is nothing but your measure value is 115 volt, which is guaranteed accuracy is plus minus of 0.5%. Okay, plus minus of 0.5% into full scale value. What is the full scale value is 250 volt. 250 volt. So find out this limiting error here. This is your plus minus of 0.5%. 250 divided by 115. Find out this, put this value in your calculator. किसी का आंसर फाइनल आंसर आएगा तो बताना, ठीक है? Limiting error is nothing but here is plus minus of 0.010. Percentage limiting error is nothing but your plus minus of 1.08 percentage. Okay. So this is your limiting error. Now okay, this is the value of this percentage limiting error. One more thing, this is a percentage limiting error. This calculation is valid for the percentage limiting error. Okay. When you do this calculation, you will get the percentage limiting error. Now this 0.5% of this accuracy class is given on your this full scale value, means 250 volt of your full scale. What are the this percentage is equal to x percent, x value, right? Let's say this is your x value. So when you solve this, you will get for you. So when you solve this, you will get x is nothing but your plus minus of 1.25, right? When you solve this, so you will get x minus plus minus 1.25. So these are the variation, right? These are the variation, absolute variation, absolute deviation from your actual value, from your full scale value. So while the measuring the this true value of 115 volt, so these are the maximum deviation. So by this way, you can also find out this limiting error, percentage limiting error, uh, by this second method. ऐसे भी आप सॉल्व कर सकते हो इसको. So this is your 115 volt, 115 volt. You got some error, percentage error here, and what are the maximum deviation you have for this meter is plus minus of 1.25. So when you solve this problem, okay, so when you find out this x value in terms of your percentage, here the value of x is nothing but your in terms of percentage. So you will get here plus minus of your 1.08%, right? By the same way you can easily find out this, but absolute value is nothing but your plus minus of this 1.25. Okay. ये रिलेशन से आपको यहाँ पे आपने परसेंटेज वैल्यू लिया था, तो आपको डायरेक्टली ये दिस प्लस माइनस ऑफ दिस वैल्यू यू विल गेट हियर. But you need, when you need to find out this value, सो आप ऐसा भी कर सकते हो, राइट? दो वे है इसको सॉल्व करने के. सो फर्स्ट थिंग इज दैट टू फाइंड आउट दिस वैल्यू, एंड सेकेंड to know the absolute error. So what are the measuring value is 115 volt, right? Into plus minus of this in terms of percentage, right? So this is nothing but 1.08 divided by 100. So which is nothing but a plus minus of absolute error. Absolute error, right? So the only thing is that uh, either go through this method or use this formula and find out this value in terms of percentage. Then you can uh, uh, calculate the absolute error. So by these two methods, you can find out this. So similar way, find out the value of this ammeter. Okay, ammeter के लिए find out करो. And this watt meter, watt meter के भी full scale value दिया हुआ है, and measuring value different है. So by this way, calculate these all things. So I just write down here the conclusion, which is nothing but here. For example, for emitter you will get 2.5 ampere, right? So for 2.5 ampere, what are the percentage value is, you will get here plus minus of 0.025. So this value is come will be came from this full scale value. Okay, full scale value. So plus minus of 0.5% is for 5 ampere, is for 5 ampere. So is for 5 ampere, but and this percentage in terms of absolute error you will get 0.025. Okay, for this ampere. So same way, for this x value you will get here plus minus of 1% when you solve this problem. For voltmeter का तो मैंने अभी बता दिया आपको. Okay, for wattmeter, for wattmeter, what is the percentage value is plus minus of 1% for your full scale reading. Full scale reading is nothing but your 500 watt. Okay, so for this 500 watt, for this 500 watt, what is the absolute error is 500 multiplied by 1 divided by 100 is equal to your absolute error. When you solve this, you will get plus minus of 5 watt. Okay, plus minus of 5 watt. So but the actual measuring the power, actual power you will get here is 220 watt. So 220 watt के लिए कितना होगा, is nothing but your 220 multiply by x divided by 100. This x in terms of percentage. Okay, so which is give the absolute error here is plus minus of 5 watt. So when you solve this, you will get this x value is nothing but your plus minus of 2.7 percentage. Okay, now the power formula, power factor cos phi is nothing but your p by vi. So see here all the multiplication and division are used. So you need to error in terms of percentage. So we already find this error in terms of percentage here. This is your plus minus. So simple, do two calculations. First is absolute actual value calculation, which is nothing but here what you get the power is 220 watt. Okay, or you can directly use this. Okay, so this is your 220 watt, and voltage is 115 volt, right? 115 volt, no? Yes, voltage is 115 volt, and current is 2.5 ampere, 2.5 ampere. So this value you will get here is 0.75, 0.76. Okay, 0.76. Now add this all percentage error. Okay, so what are the all percentage error here? Plus minus of, you need to add this all percentage error. इसमें या तो इसी में दिखा दो या फिर अलग से दिखा दो इसको. ओके, परसेंटेज एरर error in cos phi, you can say that न्यूमरेटर में कितना था, पावर के साथ कितना था, परसेंटेज एरर इज प्लस माइनस ऑफ 2.27 percentage, and here is 1% and 1.08%, right? So this is your 1.08% into 1%. So add this all these percentage values here. So while performing multiplication and division, so this all value percentage value will be added, always added. 2.27% plus 1.08% plus 1%. Okay, these all value are in terms of plus minus. So when you add this, you will get 4.35 percentage. So your power factor, take the combination of these two, cos phi is nothing but your 0.76 plus minus of 4.35%. ओके, ये आंसर आया कि नहीं आया आपका? Yes guys, you can also convert this percentage value in term in absolute error. Okay, you can also convert this value in terms of absolute error, and you can specify the range of this cos phi power. Okay, so convert it and find this answer in terms of range. These are the third question. So these are the very easy question, and similar types of problem we also uh, do in our previous lecture of unit number 1. Okay, so I skip this problem, or you can solve this problem, and or you can solve this problem and tell me the answer in your next lecture. Now this fourth problem, see that problem. A Wheatstone bridge is balanced with the four resistance equal to 1 kilo ohm each. Okay, so balanced Wheatstone bridge are given here. So let's draw the circuit. So this is your general circuit diagram of Wheatstone bridge. Each bridge has contain 1 kilo ohm resistance, so which is nothing but your 1000 ohm resistance. So I consider this 1000 ohm. This is your 1000 ohm resistance. Okay, according to that question. And okay, supply voltage is 100 volt. So this is your 100 volt battery is connected to this bridge. Now the value of one of the resistance is changing to the 1010 ohm, means there is a deflection uh, by the value of 10 ohm. Okay, so कोई भी resistance का आपका, so this is the Wheatstone bridge, so balance Wheatstone bridge, so if the deflection for this galvanometer is 0, okay, for the balance condition, but when you change the value of this bridge to 1010 ohm, so let's say I changing the value of this branch to the 1010 ohm. So when I change the value of this branch resistance, so this bridge is become a unbalanced bridge. So let's name the bridge A B C D. Okay, So uh, so what you need to find out here, the output voltage is measured with the voltage measuring device of the infinite resistance. See, the voltage measuring device of the infinite resistance कब था? When the bridge is balanced. So this, when the bridge is balanced means no current is flowing in that circuit under the balance condition. So under the balance condition, these parameters observe the infinite resistance, then only the no current is flowing in this branch. Okay. But when the bridge become unbalanced, then the current will start flowing from this, or you can say the potential difference is created between these two nodes. So that potential you need to measure here, right? While one of the branch is changing to the 1010 ohm. So, and sensitivity you need to find out here, find out the bridge sensitivity here. So first of all, what is the mean by sensitivity is change in output upon changing input, right? So here input change, what are the input changing here is, change in input is nothing but your change in your resistance here for this circuit. Change in input is nothing but your कितना था earlier is, what are the new resistance here is 1010 ohm. What are the old resistance here is 1000 ohm. So what are the change in input is 10 ohm. Okay. uh, so this is nothing but your 10 ohm. Now similarly, what are the change in output if I consider here. So here we need to find out the E, okay, voltages. So what are the earlier voltages is 0 volt, because this bridge is balanced. Under balance condition, no current flowing from this bridge, or you can say this potential are same. Okay. So under balance, uh, for change in output is, for the this E is nothing but your second condition. Okay. This is the output, you can say the output change in output is nothing but your E volt. And here E volt you need to find out. Okay. You need to find this E volt. So E volt is your change in output. What are the initial voltages? 0, because the bridge is balanced. So what is the change in output is nothing but a E volt. And this E volt you need to find out. I consider this one of the variable. You can also use another variable. Okay. Now, so yes, so this is nothing but your change in output. Now, how to find out this E? The circuit is simple, like just like that. Now this 1000 ohm is become 1010 ohm. So here you need to find out the potential between these 2 point. So this is I consider here, let it be, E is nothing but your VB minus of VD. Okay, I consider this potential is higher than this. If I am right, then I got my answer in terms of positive. If I am goes wrong, so I got in terms of negative. Okay. So that depends on your consideration. Then you can reverse the polarity as well. Okay, VD minus VB भी ले सकते हो, but I consider this. Let's check what I get here. Now you need to find out the VB. So how to find out the VB? How to find out the VB? So this is nothing but your, yes. For finding the VB, there are number of methods. You can use that method, or you can use that method. Okay. Or if I directly apply the voltage division rule here. Okay, because this circuit is connected in parallel with this 100 ohm of supply. So if I directly use this 100 ohm of supply to this point of node, and take the uh, voltage division rule for this series combination within this circuit, then what is the value? for this v for this potential you will get 1000, right? 1000 ओम मीन्स जिसके अक्रॉस आपको वोल्टेज फाइंड आउट करना है उस ब्रांच का रेजिस्टेंस डिवाइड बाय सम ऑफ दैट ब्रांच रेजिस्टेंस दिस 1000 प्लस 1000 दैट इज 2000. Okay, multiplied by total voltage supply is 100 volt, uh, minus of what are the branch voltages here is this is for this potential is starting from this branch, okay, this branch only, and for this same the for this potential is starting from dealing with this branch. So this is nothing but your 1000, and this is 1000 plus this 1010 ohm, which is nothing but your 2000. Okay, 2010 ohm multiply by 100. Now see, this is 2010, so it becomes a lesser value compared to this, so our E will be positive here. So our assumption is right. Okay, this potential is higher than this potential. So when you solve this problem, you will get here is 50 minus of solve this, you will get some value here. Okay, now E value which I have, which is nothing but your 0.248 volt. So you will get this 0.248 volt. So this is your E value. So we already seen the formula of sensitivity. Sensitivity is nothing but your change in output. Change in output here is E. Okay, what is the change in input for this circuit is 10 ohm. So put that value in this circuit. So you are able to find out the sensitivity of your circuit, which is nothing but your 0.0248, and the unit is volt per ohm. Okay, so you can also specify this value in terms of millivolt per ohm. So when you consider this millivolt, 24.8 millivolt per volt per ohm, or you can say this is nothing but your 25 millivolt per ohm. Okay, I hope this problem is clear to you. Mm, yes guys, now still we have 5 minutes, so try to solve this problem and tell me what you get your answer, or if you have any doubt for this session or regarding unit 1, so you can ask now. जब तक सॉल्व करो इस क्वेश्चन को.